Hello everyone, welcome to Network Jungles. Today we talk about the FLSM of Class B Private IP. So already we talk about in the previous video subnetting and Class C Private IP and IPv4 in detailed manner. If you have any doubt, you can refer the previous video. Let's start with the FLSM of Class B. So first one is the subnet table. So subnet table is the important table for referring to calculate the host portions, network portions and subnet mask, then available host, then usable host. So once again you have to recall the subnet table. So it is the manual calculation and the main calculation is the important for everything. Next. Here, so FLSM of Class B Private IP. So here the required host machine is the 1000. That is the 1000 valid IP address is required for the protection area. Here, so already we know Class B Private IP starting from 172.16.0.0 to 172.31.255.255. It is the /16 subnet. Here we used the concept of FLSM. So that is the fixed length subnet masking. So the subnet mask will be constant or fixed for the entire subnet. Here, so let's take the paint. So already we know to find the host number of bits using this formula 2 power of h minus 2 greater than or equal to 1000. So we need to choose the host number bits. For example, if h equal to 8 means we get the value 256 host IP. Then h equal to 9 means so 2 power 9 equal to 512. So we need to choose the h equal to 10. So 2 power 10 minus 2. So 2 power 10 equal to 1024. So 1024 minus 2, you get the value 1022. So our requirement is the 1000 host IP. So now we got the 1022 IPs. So we need to choose the h equal to 10. Here. So our requirement is the 1000. So based on the formula we find out the host number of bits, that is the 10. So IPv4 is the 32 bits. So 32 minus 10, we get the n equal to 22. So we need to use the subnet value is /22. So first 22 bits are network portion, remaining 10 bits are host portions. Next. So /22. So /22 means, so what is the subnet mask? Here. So IPv4 is the 32 bits. So it can be divided into 8 portions. We already know. So 8 plus 8, 16. So 16 plus 8, 24. So here 22 bits are network portions. Remaining 10 bits are host portions. So it can be represented as h, then network portions. So if all the bits are 1 in the subnet mask, so it can be denoted as network portions. So 8 plus 8, 16. 16 plus 6, 22. So host portion can be represented as 0. So here we already know. So the summation of all the values can be in decimal form is 255. Dot. Here also all the values are ones. So the summation of all the values becomes 255. Here 128 plus 64 plus 32 plus 16 plus 8 plus 4, the total value is 252 because last two bits value is 3. So 255 minus 3, it becomes 252. Here anything multiplied by anything 0, so total value is 0. So these subnets can be used for the slash 22. So 250.250.252.0. Let's use this subnet. For example, in class B, so class B IP address we have to choose the 172.16.0.0 is the network mask. So we use the slash 22. Here we need to change the last 10 bits. It can be written as binary form 172.16.0.0. So last 2% I can be written as binary form. Only last 10 bits will be changed. First 22 bits can't be changed because it is the network portions, it becomes the host portions. So how the value is incremented? So we know already it can be incremented by 1 by 1. So 1, 1, 0, 1, 1, then 100, then again 101. It can be incremented successfully. So here it is the equivalent is 0, 1, 2, 3. So the final value is the 255. After that 0.255, it can be changed to 1.0. Then it also can be incremented by successfully. The final value is the 1.255. Likewise, so another value is the 10.0. The final value for this segment is 10.255. Same 11.0. The final value is the 1.255. So after that the bits cannot be changed because we reach the final value for the segments. So 0, 0. So first LAN segment is the 0.255. Then it can be incremented by 1. So 01.0. So the final is the 01.255. Then next one is the 1.10.0, 10.255. So in each segments we have the 250 IP address approximately. So 250 plus 250, then 4 segments. So 4 into 250, we get the value of the 1000 values. So 0.1 segment, 1.1 segment, then 2.1 segment, then 3.1 segment. So we get the 4 subnet. So in each portion we get the value of 255 IP address. We get the value of 1020 approximately. So 250 into 4, 1000, 5 into 4, 20. That is the 1020. Here, same. Refer the paint. So here is the different segment. So 172.16.0.0/22. So the starting point is the network address is the 172.0.0. So starting IP is the 1.0. Here 0.1 is the first IP, valid IP for this segments. Then final IP is the 3.254. Here 11.255 is the last broadcast IP. Then previous IP address is the last usable IP address for this segment. So 11 equivalent is the 3, 10 equivalent is the 2, 01 equivalent to is the 1. 3.254. Then last broadcast IP is the 172.16.3.255. Here is the 172.16.3.255. Likewise, again, so 0, 1, 2, 3. 0, 1, 2, 3. Likewise, you can say write the another segment 4. So 4.0/22. So we need to choose the successive 4 segments. So 4, 5, 6, 7. So 4.1 is the starting IP, 7.254 is the last usable IP, 7.255 is the broadcast IP for the segments. Next, so 7.254, then next segment is the 8.0. So 8.0, we can choose the next successive 4 IPs. So 8.0, 9.0, 10.0, 11.0. So 11.254 is the final usable IP, 11.255 is the broadcast IP. Likewise, 12.1, 13.1, then 14.1, then 15.254 is the last usable IP for this segment. So final value is the 172.31.1, 12.0, then 12.0, 12.1, then 15.254. So 12, 13, 14, 15. So we choose the 4 segments. So 4 into approximately 250, we get the 1000 valid IP address for this IP. I hope you got the clarification for the class B, how to choose the network segment based on the formula. So we use the /22 subnet to choose the 1000 host. Here is the subnet mask. So if any changes in the subnet mask, then network segment will be changed. Let's take the another example. Here, so another example is the 120 host. So based on the production area, they require the number of systems in the production purpose. Here 120. So how to calculate the 120 host based on the formula? So 2 power h minus 2. We already know we can easily calculate the based on this formula. So if we choose the h equal to 8 means we get the value of approximately 256 systems. So 256 minus 2, that is we get the 254 host IP. For example, if we choose the h equal to 7 means, so 2 power 7 equal to, that is 128, 128 minus 2, 126. So we can choose the h equal to 7. So how to calculate the subnet? So 32 minus 7, we get the value of /25. So /25 is the subnet value. Then so 32 portions, 8, 8, then 8. Please find the subnet mask. So how to calculate the subnet mask? /25. Here first 3 portions can be covered the /24. Here final portion having the 8 bits. We need only the 1 bit in the network portions. So if all the values ones, the subnet mask value is 255. Dot 255 dot 255. Here is the last portions. So last portions we know. So 2 power 7 equal to 128. So 128. Remaining bits are 0. Here is the /25 subnet mask is the 258.258.258.128. Let's check the subnet mask. Yeah. So 255.255.255.128 is the subnet mask for the /25. In a segment, it can be divided into the two portions. For example, one segment having the 256 valid IPs, it can be divided into two. We get the two segments 128. So our requirement is the 1120. So that is the network address, broadcast address. Then here also sample the 128 is the network address, 255 is the broadcast address. The IP range starting from 1 to 126 for this network segment. Here 129 to 254. Let's take the paint. I clarify the doubles. For example, we can choose the 172.16.0.0. So we use the subnet /25. It can be covered the last portion of the IPv4 bits. So 172.16.0.0. So it can be written as decimal form. So final portion can be written as binary format. First 25 bits cannot be changed. Yeah, it can be, already we know, it can be incremented by 1 by 1, 1 0, 1 1, then 100. So final value is the 1 1, 7 bits of 1. Yeah. So in the previous video I can explain. So before the, here is the value is the 2 powers n equal to 128. So before the all the bits value is 1, the value becomes 127. So I can explain in the previous video. So this is the decimal number 172.16.0.0 to 172.16.0.2 127. This is the network segment 172.16.0.0 to 172.16.0.127. This is for one LAN segment. For example, next value is the, it is incremented by for the next segments. That is the next usable IP address. So it's also incremented by 128. So the network mask is the 128. So final value is the, if the all the bits is 1, the last usable IP address is the 254. So final IP address is the broadcast address, that is the 255. Then 128.22 255. A single network segments can be divided into the two portions based on this subnet value. Let's refer the subnet table here. So 172.0.0/25, that is the network ID. Here also I can return the network ID. So that starting from the IP address, valid IP address 1. So final IP address is the 126. Broadcast IP address is the 127. Next 127, next IP address is the 128. That is the network ID /25. So 128 is the network ID. First valid IP address for this segment 129. Then last valid IP address is the 254. Then broadcast IP address is the 225. Likewise, only the second portion will be changed 1, 2, 3, then incremented by successfully. So final value is the 172.31.255.128. So 129 is the valid IP address starting from ending to 254. Then last usable IP address is the 254. Then broadcast IP is the 255.255. Let's take the another example for the class B. Here is the 30 host. So simply you can firstly 2 power 5 equal to 32. So 32 minus 2, 30. We choose the h equal to 5, n equal to, so 32 minus 5, 27. Subnet mask is the 2 to 4. Here, in each segment we know 256 valid IP address. We need the 30 host. So in each host we can choose the, so 2 power 5 is the 32. So it can be divided into 32. We get the how many network segments? That is the 8 segment. So 30 into 8, 240, 2 into 8, 16. 240 plus 16, 256. So any IP range can be starting from 0 to 31. That is the 32 starting from 0 to 31. So it can be added by 32. So 0 plus 32, 32. Next 31 plus 32, 63. Likewise. Then 64. 32 plus 32, 64. So 64 plus 32, 96. 96 plus 32, 128. 128 plus 32, 160. 160 plus 32, 192. 192 plus 32, 224. Likewise. So 63, you can write plus the 32, or otherwise you can write the value, that is the network segments. Here 96, you can write 95. So it is the easiest way. So 128, here is the 127, here 160, so 159, here 192, so final value is the 191, then 224, so 223. So we already know last usable broadcast IP is the 245. So this is the one way of tree. So first portion is the, it belongs to the network portions. Then last portions is the broadcast address. So it belongs to the network address, it belongs to the broadcast address. Between the range it can be used for the valid IP address. So 0, 31, between the IP range 1 to 30, for example. Here, so 0 is the network address, 31 is the broadcast address. So between the range valid IP address is the 1 to 30. So our requirement is the 30. So we get the 30 valid IP address. Likewise, so 32. 32 is the network ID, 63 is the broadcast ID. So 33 to 62 between the range. That is the 62 between the range, we get the value of 30 host IP address. Likewise, 64, 96, then 128, 160, 192, 224 is the network address. Likewise, 95, 127, 159, 191, 223, 245 is the broadcast address. So between the range you can use the valid IP address for the host machines. This is the honest way of to calculate the usable IP address without any paper document. Here, so 0, 1, 30. So already discussed in the previous slides. 32 is the, so 0 plus 32, 32, 32 plus 32, 64, 64 plus 32, 96, 96 plus 32, 128. Likewise, so 224 is the last segment for the this network area. Then likewise, now you clarify about the how to calculate the subnet mask, then how to assign the valid IP address, then network segment based on the different host requirement area. Thank you. I hope this video useful for you. Thanks for watching video. Click the bell button to subscribe. Let's see on next jungle video. My next video is the Class A FLSM.